Hi folks, we're going to take a look at page 14, number 10 from the unit assignment. So here they give us this triangle with these vertices, and they want us to find the largest angle, and then they want us to find the area of the triangle. So let's start with the angles. Okay. Now here, since we're given information in algebraic form, it makes sense to determine the angles using the dot product. Okay, so first thing I have to do is I have to set up my vectors. Okay, so notice I have to put them tail to tail. So what I'll do is I'll put A, B, and A, C. I'll draw them like that, which determines my triangle. So I'll look for this angle theta first. Okay, so let's find AB. So let's let U be AB. And what is that? We've got 0 minus 2 is negative 2, negative 3 minus 3 is negative 6, and 4 minus 7 is negative 3. Okay, so that's one of my vectors, and vector U can be AC. Notice has to start from the same point. So even if you weren't drawing the diagram, if you're comfortable with that, notice that whatever you start with in the first, you got to start with in the second. So AC, we've got 5 minus 2 is 3, 2 minus 3 is negative 1, and negative 4 minus 7 is negative 11. Okay, and now that we found the two vectors, we can use the dot product. So recall that we use both the algebraic and geometric definitions. So U dot V is just the magnitude of U times the magnitude of V times cos theta. So U dot V here is, what do we have? We have negative 2 times 3, negative 6, plus negative 6 times negative 1, so plus 6. And here plus negative 3 times negative 11, so that's going to be plus 33. And here we got the magnitude of U, which is 4 plus 36 is 40, plus 9 is 49, so square root of 49 is 7. And then here we've got 9 plus 1 is 10, plus 121, so 131, so square root of 131 times cos theta. And so from here we can just determine theta. Let's do that. What do we got? So this ends up just being negative 6 plus 6, 0, so 33. So here we've got cos inverse of 33 divided by, don't forget to put your brackets on that multiplication, 7 times square root of 131. And we've got 65.7. So the angle there is 65.7 degrees. Okay, so now basically all we need to do is find a second angle. We don't have to find the third since we can just determine that easily. Okay, so here let me start from another point. So let me start from B. Okay, so let's do BA and BC. So BA is equal to 2 minus 0 is 2, 3 minus negative 3 is 6, and 7 minus 4 is 3. Okay, and then let's find BC. Okay, so BC, we've got 5 minus 0 is 5, 2 minus negative 3 is also 5, and negative 4 minus 4 is negative 8. Okay, I won't write out the equation here, so now let's determine the angle at B. So dot product, 2 times 5 is 10, 6 times 5 is 30, so plus 30, and 3 times negative 8 is negative 24, so minus 24 equals the square root of magnitude of this one here is, I just realized actually, just by the way, when I found BA, I actually didn't need to find BA since it's just the opposite of AB. I could have just taken the negative of it. Okay, so magnitude, we already found the magnitude of AB is going to be the same as BA, and that was our 7 there. So we got 7 again. Magnitude of BC is 25 plus 25 is 50 plus 64, so that's square root of 114 times cos theta, and so theta is equal to, okay, what is this equal to? 40 minus 24, so that's just 16. Okay, so let's do this here. Oops, bad time for the calculator. Oh, there we go, came back to life. Okay, so what had we said here? We had 40 minus 24 is 16, so we've got cos inverse of 16 divided by 7 times the square root of 114. Okay, and 77.6. So 77.6 degrees. So already that's larger than the other one. And when we consider the third angle, well, you know, this is 80 plus 60 is 140, so the third angle is going to be, you know, around 40 degrees, a little less. So definitely that's not the largest angle. So here we can say largest angle is approximately 77.6 degrees. And I just realized that's not part B, it's part of part A. Okay, so there we go. Again, good use of the dot product. Now in B, the real B, they want us to find the area of the triangle. Okay, now let's recall that we have another one of our operations that gives us the area of a parallelogram. Okay, so what gives us the area of the parallelogram? Well, it's just the magnitude of the cross product between the two vectors that define the parallelogram, and so the area of the triangle is just going to be half the area of the parallelogram, so half the magnitude of the cross product. Okay, now it doesn't matter which two vectors I use to define the triangle or the parallelogram. Either one should work. So I'll look at my two sets of angles, and I've got these here and I've got these there, not angles but vectors, and I don't know, this one here looks a little easier, so I'll do that one. Maybe I'll even do both just to convince you that it is going to be the same. Okay, so the area of the triangle is going to be the magnitude of the cross product of these two vectors. So 2, 6, 3 cross 5, 5, negative 8. Okay, so let's find the cross product here. So 2, 6, 3. Whatever method you use to do this is fine. 5, 5, negative 8, another 5. Okay, so these numbers are a little large, so let's take our calculator to help us out here. There we go. So what do we have? So first, to find the x component, remember we have to use the y and z components. So here we've got negative 48 minus 15, okay, negative 63. Okay, then to find the y component, we're going to use the z and x. So here we've got 15 plus 16, well, that one's easy, 31, don't need the calculator for that. And then to find the z component, we use x and y, so 10 minus 30, negative 20. Okay, so there we go. And now let's find the magnitude of this here. So this is negative 63 squared plus 31 squared plus negative 20 squared. Okay, and let's calculate that there. To get in the light. Okay, so square root of 63 squared plus 31 squared plus 20 squared, and we get 73. Okay, but of course, let's not forget that we're finding the area of the triangle, so we got to divide this by 2, divide this by 2, divide this by 2, and divide this by 2. So good thing I remembered that. So 73 divided by 2, well, 72 is 36, so this is 36.5 units squared. Okay. Now, just to kind of check that this does work out with any vectors. Let's do it with the other vectors. So let's use -2, -6, -3. Okay, so this will just be a check. So I won't be as careful with the communication. And so -2, and the other vector was 3, -1, -11. Okay, and let's find the cross product here. So here we have 2 minus -18, so that's 20. Okay, here we've got 66 minus 3, so 63. Actually, this one looks like it turned out to be easier than the other one. And here we got -9 minus 22. -9 minus 22 is... Oh, sorry, yeah, -9 minus 22. And that seems odd. Oh, there we go. -31. There we go. All works out. Now, I'm not even going to bother finding the magnitude of this here because I see that the three components all have the same absolute value as the three components of my other vectors. So I know that when I square them and add them and take the square root, I'll get the same value. Okay. So that's it for this one. Just to recap, remember to create a triangle or a parallelogram, place two vectors tail to tail, and that defines either a parallelogram or a triangle. Okay, and that to find angles, use a dot product, and to find areas, use a cross product. Okay, that's it.